Today we're going to look at Eratosthenes' sieve. So our goal is to understand the difference between prime and composite numbers and identify multiplication patterns. So, of course, this is an activity that helps you not only look at prime and composite numbers, but also look at divisibility patterns. If you're one of those middle schoolers that struggles with multiplication, this is definitely going to help you, and it's going to help you save time as well. So when you do this activity, you're going to need to make sure that you have a copy of the hundreds chart that I gave you, as well as a pencil and at least 4 different colored pens or markers. So if you need to pause this video to get those supplies, go ahead and do that now. So some background. If you've ever made cookies, you may have used a sieve to sift flour. It's a device that has tiny holes and it lets fine particles through but retains big lumpy bits of things. So Eratosthenes was an ancient Greek athlete and astronomer and mathematician. His sieve doesn't sort out lumps of flour, but it sorts out prime numbers. So a prime number is a number that can be divided evenly only by 1 and itself. So divided evenly in this context means the result is a whole number with absolutely no remainder. Okay, so here you have your own hundreds chart. So the first step we have is using our pencil, we're going to draw an X through the number 1 on our hundreds chart. So we're going to draw a little X on number 1. And the reason why is because number 1 is special. It's not prime because a prime number has to be evenly divisible by 2 numbers, 1 and itself. The number 1 is divisible by only one number, 1. So it's not prime, it's also not composite. So 1 is just special. So we put a little X through 1. So the next thing we're going to do is look at number 2. The number 2 is prime because only 2 numbers can divide into it evenly, 1 and 2. So you're going to circle the number 2 with your pencil. So we're going to circle 2. So for your next step, you're going to use your yellow marker to draw a vertical line through the center of the box the number 2 is in. So we have multiples of 2. Just the center. Whoops. Then you're going to find all the other multiples of 2 in the chart, and you're going to draw the same yellow vertical line through each of them. So for example, look at 3. Is 3 a multiple of 2? Determine that. If it is, put a yellow line just through the center. Don't scribble all over it. Go ahead and pause the video and do that now on your own. Now I want you to check your answers with my own. So of course, all multiples of 2 we have are even numbers. Anything that's even other than 2 itself is composite because they can all be divided by 2. So 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. So you might notice a pattern going on. And make sure on your key at the bottom that you're bubbling in the color that you're using, yellow, for your multiples of 2. So notice how basically half the numbers are divisible by 2. So now you're going to look at the next number on the top row, 3. Is 3 a prime number? Well, it is, because 3, of course, is only divisible by 1 and itself. So you're going to circle the number 3 with your pencil. Using your red marker, you're going to draw a diagonal line across the box containing the number 3. And of course, multiples of 3, whoops. You're going to do the same thing in that box as well as your key. And this is where using a highlighter can really help, but if you don't have a highlighter, that's absolutely fine. So using the red marker, draw the same diagonal through all the multiples of 3 on the chart. So, for example, the next multiple of 3 is the number 6. So you're going to draw a diagonal through the 6. Find all the multiples of 3 between 6 and 100. Go ahead and pause the video to do that now. Now I want you to check your answers with mine. So of course we can count by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, and you might notice another pattern here. So notice all of our multiples of 3 do have a pattern on this number line. So now I want you to notice that some boxes in your chart have both a yellow vertical line and a red diagonal line. These numbers are multiples of both 2 and 3. If a number is a multiple of 2 numbers, it's also a multiple of those 2 numbers multiplied together. So the boxes show you that multiples of 2 times multiples of 3, so let me write that for you. 2 times multiples of 3 are multiples of 2 times 3, or 6. So mark this in your key too. So we have multiples of 6 are going to have both the yellow horizontal and the red diagonal line. Continuing along the top row of the chart, notice that 4 is already marked with a yellow vertical line, reminding you that it's a multiple of 2, so it can't be a prime number. So then the next number is 5. 5 is prime because the only multiples are 1 times 5. So go ahead and circle that with your pencil. Now use your green marker. You're going to draw a vertical line through the 5 and draw this green line a little left of the center so that you don't cover up any of the yellow lines. So now you're going to find all the multiples of 5 in the chart and draw the same green line through each of them. The trick to finding multiples to 5, of course, is to look for numbers that end in a 5 or a 0. Look for that pattern and it'll help you find all the multiples of 5 in your key. You also might notice some specific patterns there as well. Now I want you to check your responses with mine. So of course 5, 10 is also a multiple. And we notice that we have this huge column that ends in zeros. So of course anything that ends in a 0 is a multiple of 5. And anything that ends in a 5 is a multiple of 5. So there are some patterns here. We notice that we have some that have both a green and a red line. Some have both a green and a yellow line. And some have both a green, yellow, and a red line. So that tells us some connections that we have. So now we're going to make sure that we have in our key that we put that vertical green line multiples of 5. Then we need to look for patterns. So multiples of 10. Well, looking at our key in our chart, we can figure out what set of colored lines show us the multiples of 10. Well, here's a hint. 2 times 5 equals 10. So what colors should you use for your key for 10? Well, you can look at all your multiples of 10, and we can see that they should have both a yellow and a green line through them. Now we're going to look for multiples of 15, which of course, another hint, is 3 times 5. So look for the patterns that we see multiples of 15. You're also going to look for multiples of 30. Here's another hint. 3 times 5 times 2 equals 30. So add those to your key. Go ahead and take a minute to pause this video and find those on your own. So multiples of 15, of course, we have 15, 30, 45, 60, 75, and you notice that some of them have 3 colors, some of them have 2. So we have to, of course, look for the ones that have all the same. So we have the red line and the green line. Whoops, let me make sure that color is correct. And the green line are the multiples of 15. Now, times 2, we're just adding that yellow line, which of course times 2 means that it's a multiple of 2. So we have the yellow line, we have the green line, and we have the red diagonal. Those are our multiples of 30. Last but not least, we're going to look at the number 7. That's the only number on the top that we have that is not circled. So 7, of course, is prime because it's only divisible by 1 and itself. And now we can look at the multiples of 7. Go ahead and take a minute to use your blue marker, and you're going to draw a diagonal, the opposite direction of the red diagonal, for the multiples of 7. And make sure you mark that in your keys. Go ahead and take a minute to look at the multiples of 7 right now. So to review, we have, of course, counting by 7, 7, 14, 21, 28, 35, 42, 49, 54, 56, 63, 70, 77, 84, 91, and 98. So those are our multiples of 7. So now I want you to ask yourselves a few questions. Can you figure out what set of color lines shows you the multiples of maybe 14 or 21 or 35? You may put those on the back of your key if you like. Continuing along the chart, notice that, of course, 8, 9, and 10 are already marked. So there are no prime numbers left on the top row. All the numbers that haven't been marked yet are the remaining primes between 1 and 100. So go ahead and take a minute to circle all the remaining primes between 1 and 100. So it can't have any of the other colors around it. You're circling those primes. Go ahead and take a minute to do that now. So your hundreds chart should look like this, and I hope I haven't missed any. If I did, make sure you let me know, and I can circle them on my final copy as well. So here are everything that is circled are prime numbers. Another thing you want to put in your keys. And now you have all your patterns up to 100 done for you. So make sure you keep this sheet and make sure that you refer back to it for help. So again, great job today working on Eratosthenes Sieve. And now, of course, you've not only learned a little bit about prime and composite numbers, but you've determined quite a few number patterns. And this will help you, of course, not just in prime and composite numbers, but in factoring, finding multiples, and in your multiplication in general. So good job today.